Very good afternoon and welcome to this session of CAD Camp. We were discussing about computer integrated manufacturing from previous 2-3 lectures, and today also we are going to discuss the remaining part of it. Let me share the screen with you. Okay, can anyone just tell me if this slide is visible to you? Is it visible to everyone? Just send me a message. Yes, okay. So let us start with SIM. Actually, we have already discussed about SIM in previous lecture. So uh, let the others join. Till that time, we will take the short review of what we have already discussed. Okay. So we have discussed about the definition of SIM. Just a second. Okay. Okay, we have seen the definition, what is exactly mean by SIM, how the Society of Manufacturing Engineers or other uh, industries or other organizations define SIM. Okay, then we have discussed about different types of production systems, its features, what are the challenges are faced by the engineers in the industry, like reducing the cost, reducing the delivery time, upgrading or improving the quality. Okay, then we have discussed other features. What are the different constituent parts, or what exactly SIM comprises of, that we have already discussed. Then we have seen the benefits of SIM. Uh, Different benefits are there that we have already discussed in percentage. We have discussed about the hardware which is utilized for implementation of computer integrated manufacturing in an industry. These are the different types of hardware devices that were used, manufacturing devices rather. These are the hardwares which under the category of drawing equipments. Then we have seen the softwares which are used for SIM implementation, different types of software, not exactly the software, but the thing or the process where this software is being used. We have not discussed the names of the software, rather we have discussed the requirement of the process, what process we require, want to do, and also what exactly we are using as a parameter or as a basis to select the software, that were discussed in this part. Then there are elements of SIM. Nine major elements are there: marketing, product design, planning, purchase, manufacturing, engineering, factory automation, hardware, warehouse, finance, information management. These are the nine major elements, and I have told you that there are other elements also, but these are the nine things that you should completely known of. And this is just a diagrammatical representation of these elements that you might be remembering from the previous lecture. Then we have discussed already about the objectives of SIM, I guess, and database requirement, which is very important part of the computer integrated manufacturing. Whenever you are going to implement such kind of thing in an institute or in an organization, in a shop floor, industry, wherever it is, you have to use the database. Database is the most important part of any computerized system, because on database only you will be required, you will be having the processes you are doing on the database, you are using the database, you are storing the database, you are retrieving the database. So that is why database is of very much importance. We have already discussed about this. Different types of database were discussed, like product data, manufacturing or production data, engineering data, operational data, resources data. Okay, this is just a diagrammatical representation. We have already discussed about that. These are just the data which are required, and what exactly in that we require, that we have already discussed in previous lecture. we have objectives of database already discussed in previous lecture. Issues of concern we have discussed, and we were at this point the role of CAD/CAM in computer integrated manufacturing. So basically, what is computer aided design and computer aided manufacturing? That is to be understood first. Okay, so basically computer aided design is the process of designing a product by using or by taking the aid of computer, which is called as computer aided design. Okay, and computer aided design has the another part which is called as the latter part of that is manufacturing, computer aided manufacturing. So the computer aided manufacturing is defined as the effective use of computer technology in manufacturing planning and control. So manufacturing planning and control is the key term you should consider while dealing with computer aided manufacturing. You are not just going to use computer for the manufacturing process, but also you are using that for planning of the manufacturing and control of the manufacturing. Okay, so CAM is the most closely associated with functions in manufacturing engineering such as process planning and NC programming or numerical control. Basically, whenever we are talking about the automation or computer integrated manufacturing or these things, then the first thing that comes in mind that we are using a workstation or a machinery which is automated one. So those machinery are nothing but the numerically controlled machines, or we rather call it as CNC machines. Nowadays it has been also gone far away from that basic parameter of CNC machine. There are DNC systems are coming upon, then artificial intelligence and everything is just coming and adding to this computer aided manufacturing. Now this CAM can be divided into two broad categories. The first one is manufacturing planning and second one is manufacturing control. So what is this manufacturing planning? Now CAM applications for manufacturing planning are those in which the computer is used indirectly to support. We are using computers indirectly and as a support for the production function. Okay, there is no direct connection between the computer and the process. This point should be kept in mind for CAM. Okay, the computer is used offline to provide information for the effective planning and management of the production activities. I think you are getting it. We are using computers as supporting role. Also, it is not directly connected with the systems and it is used offline, not online. Okay. The areas for manufacturing planning, what are those areas? The first one is CAPP that we have discussed in previous lectures. If you remember, computer aided process planning, which is done at the starting phase of the design manufacturing. Then computer assisted NC part programming, computerized machinability data system, development of work standard, cost estimation, production and inventory planning, computer aided line balance. What are these areas? These 6-7 areas are there that are to be considered while manufacturing planning, that we are going to discuss in later part. The second type is the manufacturing control. The first one is manufacturing planning. The second one is control. The second category of CAM application is concerned with developing computer systems to implement the manufacturing control function. So the core part is to implement. What implement? To implement the manufacturing control functions, and by using developed computer system, or we are going to develop this kind of systems so that could be used for control functions. Okay, manufacturing control is concerned with managing and controlling the physical operations in the factory. Whatever the physical operations are going to be happen, that are to be controlled by that are to be said in the manufacturing control. The control of that factor is said to be in the manufacturing control. So in earlier part, manufacturing planning, the computer was not used directly, it was used offline. Here the computer is directly used and online is used for this particular controlling process. The management and control areas include process monitoring and control, quality control, shop floor control, inventory control, and just-in-time production system. Okay, we will discuss in brief what are these things or areas that are concerned with manufacturing controls. Then we also know what is meant by CAPP, computer aided process planning, the first part of manufacturing planning. Okay, the first part is process planning is concerned with the preparation of route sheets that list the sequence of operation and work centers required to produce the product and its component. These are available today to prepare these route sheets. So basically we are planning the routes of the raw material, how it is going to be transferred from one stage to another stage or one workstation to another workstation, how it is going to be transferred, when it is going to be transferred, what are the different things that are associated with this transfer or routing of this particular raw material from initial stage to the final stage. That part comes in CAPP. In that case, we are taking the help of computer. That is why this is called as CAPP, computer aided process planning. You know the NC part programming. There are two types of part programming. If you know that, if you remember the CNC part of your manufacturing process subject, okay, in that they say that computer programming, sorry, NC programming is of two types. One is called as manual part programming, and second one is the computer assisted part programming. So manual part programming, the operator is going to be the programmer and he is going to use everything, the knowledge and everything to type the program in the computer, while the computer assisted NC part programming is quite different, which is some sort of automation. So in that case, we will have some softwares installed in that particular computer, and in some cases what we can do, we can just provide a drawing to the system, or you can just provide a prototype model, a mathematical model to the system, and the system converts that mathematical model into a part program. So basically, in that case, you are using the existing database in the system for preparing the part. That is why this is called as computer assisted NC part programming. I hope you are understanding this. If you have any questions, if you don't understand what is going on, you just uh, send me a message, or anyhow you can just call, just uh, switch on your mic and ask. Okay. Then third part is computerized machinability data system. This is somewhat different. Okay, what happens in that? One of the problem in operating a metal cutting machine tool is determining the speeds and feeds that should be used. Okay, the first and important part of manufacturing is to plan for manufacturing. Okay, now what during the planning phase, what is the important part? We should know what type of component we are going to manufacture, what type of raw material we are having, what is the tool we are using. Now everything is there, but now we have to calculate the RPM, the speeds of the spindle speed, the rotation should be like that, the feeds like should be like that. Okay, now what is the importance of this? Because of this, what will happen, we can plan, or we can make it optimum, so that in minimum time maximum products could be produced. Okay, that is why it is very important to require to calculate the speeds and feeds and everything. Okay. Now, computer programs have been written to recommend the appropriate cutting condition to use for different materials. So computerized machinability data systems. Okay. Now what we have, suppose we have implemented computer integrated manufacturing system in our industry. So in earlier part, I have told you that the database is the most important part for SIM, because everything is converted into data and it is stored somewhere in the server room. Now what happens, whenever the part of machinability will be arise, or whenever the issue, or whenever the work of machinability will be taken off, okay, then you have to take the data, related data to that machinability. Now if you have that data in your database, then obviously you are going to retrieve that data and you have to use that. So now it is not a manual process. So what will happen, if you provide a drawing mathematical model to the computer system, what will it do? First it will do the analysis of the that part, what is the model is given and how manufacturing is to be done. That planning has to be done. Okay, for that planning, that will require the machinability data. What kind of material you have provided? Okay, what is its properties, its toughness, stiffness, roughness? Okay, whatever the strength and everything of the material will be there. Okay, now what happens when the computer sees, or the software sees these kind of things, it will automatically get back to that for a particular part of the data, where this all the data required for this particular material, this much should be the speed RPM, and this much should be the feed for this condition. Okay, so this is how computer programming is going to work, or is going to used for machinability data system. So that is why it is called as computerized machinability data systems. So the calculations are based on data that have been obtained either in the factory or laboratory, that relate to life to cutting conditions. So obviously tool life, cutting conditions, other parameters, the liquid, fluids, other things, coolants, okay, that are the things which are concerned or related with these things, and that data is already stored in the system. If it is not stored, then you have to generate that data, and if generation is possible in the laboratory part or the research and development area where it is situated, then you have to generate that data. Okay, so this is how computerized machinability data system is related to SIM. Next is development of work standards. The time study department has the responsibility for setting time standards on direct labor jobs performed in the factory. The time study department, okay, now the standard, what is standard, work standard? There is, whenever you go for a visit or to a industry, you will find some of these, you can call it as operating procedures, standard operating procedures, SOP. So these are some of the guidelines. So according to that guideline, the flow is always going to work. Okay, the person who is going to work on a particular job, he has to follow that guideline, that standard operating procedure. Now in that standard operating procedure, everything is predefined by using some computerized systems. Okay, now what that predefinition is done, that is called as standardization of the process. Suppose just give me a second, I will show you. Okay, suppose if you can see this part here. Okay, now you have to make, suppose this is a part and you have to make the uh, turning operation here, and you are going to use this by, you are going to make this by using SIG. Okay, now what happens, the standard working procedure, okay, to make this component is already defined. Okay, now while defining that thing, what is the standardization or making the work standard means establishing the standards for this particular operation of turning. What time it will take that standard to turn this part from this here to here, or the whole part, that time required to make this one operation is already developed. Okay, so that is nothing but the time study and standardization by using them. Okay, now what happens? Establishment of these standards by using direct time study, like using a clock method. Okay, this is the general procedure, a general method of making time study. uh, Clock is used and simulation is done, what you call it as Rangit Talim, if you remember that word. So what happens? They simulate as it is going to be manufactured, and they will record the time, and the standardization of time study is done. But this making of time study of this everything is very tedious and time consuming task. Okay. Now for that reason, there are several computer software and packages are available. They can give you setting of work standards. They have that ability, they have that inbuilt programs, inbuilt things that will convert the drawing into required time standard, how much time it should require to manufacture that particular product. Okay, these computer programs are standard time data that have been developed for basic work element that comprise any manual task. So whatever the manual task is to be performed. Now suppose this again, take this example only. So suppose we want to assemble this part with this part. Suppose it takes 5 seconds to assemble, 1 minute to assemble this part. What will happen? This is the standard time you have already developed. Okay, you have measured the time required to a standard person in standard conditions to assemble these two parts. Or you can have an example of your own. Whenever you go for buying an electronic item, or say automobile two-wheeler, so what they say that this two-wheeler gives you 80 kilometers per liter average. Okay, average running of this particular two-wheeler will be 80 kilometers, 60 kilometers, 100 kilometers per liter. So is it that happens every day? You Do you get 100 kilometers or 80 kilometers average per liter? No, because that has been tested in the standard conditions of laboratory. Okay, so that is called as work standardization. So that standardization is to be considered. Okay, this is the development of work standards. I hope you understood the thing. Okay, cost estimation, it is generally the task of estimating the cost of new product that has been simplified by computerizing several of the key steps required to prepare the estimate. Generally, how we estimate a cost? We take the raw material cost, the man cost, the material cost, the process cost. Every cost is associated, which is associated with the manufacturing and everything other things. So final cost of the product will be estimated by using that. So earlier, when there were no these kind of softwares and things were not there. Even today, some of the industries, small scale industries and micro scale industries, what do? They use that their own skills and experience to estimate the cost. But nowadays there are softwares which can estimate the cost very quickly and very precisely. They can take into account the previous performance of the different product, previous performance of same product by competitor. Then but you have to give the inputs for that. Okay, so that is most important part of that. The computer is programmed to apply the appropriate labor and overhead rates to the sequence of planned operations for the component of new product. So whatever the things that are associated with the cost of product, you have to give the input to the system. Without input, it cannot work. The program then sums the individual component cost from the engineering bill of material to determine the overall product cost. Okay, this is what I said. The overall product cost will be dependent on the different other things, but the computer will do that for you, and you will be you will be having a very competent cost that will be useful for your further plannings. Okay. Then production and inventory planning. The computer has found widespread use in the many of the functions in production and inventory planning. These functions could be maintenance of inventory record. What is the inventory is coming out, coming in, that inventory record is to be maintained by using computers. Automatic recording of the stock items when inventory is depicted. Automatic recording is there. Whenever we take out the material from the stock or inventory from the stock, it records automatically. Production scheduling is another part of that. Maintaining current priorities for the different procurement orders. So what will happen? The automatic recording will be generated and it will be uh, shown or prepared to the person who is the decision maker. So that person will see whether the stock is going to the threshold limit, the limit which is fixed. It should be fixed. If it is going down that, then we have to order the new stock or the new material. This is how it is going to work. Okay. Material requirement planning, capacity planning. These are things which are functions. Okay. Am I audible to you? What happened? Am I audible? Can anyone just tell me? Yes. Okay. 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 So what we will do, we will stop here because I think the time is up and you will be having another lecture also. So just stay online. What will I do? I will take the attendance.